In this video, we're going to be taking a look at independent and dependent variables in tables and graphs. And you will need to get out your Go Math book and turn to page 337. Get out your math journal and a pencil. Now, the essential question we are going to be taking a look at is how can you identify independent and dependent quantities from tables and graphs? Now let's take a look at the Explore activity number 1 on page 337. Identifying independent and dependent quantities from a table. And let's take a look at what that says underneath the bold print. It says many real-world situations involve two variable quantities in which one quantity depends on the other. The quantity that depends on the other quantity is called the dependent variable. Easy way to remember that. You can see dependent depends on the other quantity, and the quantity it depends on is called the independent variable. In other words, if you're independent, you don't need any help from anyone else. Okay, so dependent needs help, independent variable can stand alone. Now let's take a look at the problem. It says a freight train moves at a constant speed. The distance, represented by y, the variable y, in miles that the train has traveled after variable x hours is shown in the table. So we can see, obviously, 0 and 0, 1 hour, 50 miles, 2 hours, 100 miles, 3 hours, 150 miles. Now we can see, taking a look at this, what are the two quantities in this situation? And we can see we have a quantity of time and also a quantity of distance. So let's write that out together. So two quantities, and I'll write it over here, time and distance. Now let's take a look at which of these quantities depends on the other. So we can see time and distance. Those are our two quantities. We need to figure out, does time depend upon distance or does distance depend upon time? And looking back, we know that a freight train moves at a constant speed, and the distance in miles that the train has traveled after hours is shown on the table. So we know that distance depends upon the time. Because depending upon how much time has passed, that's how far the train has traveled in miles. So distance depends upon time. In other words, you can only have 50 miles after 1 hour has passed. You can only have 100 miles after 2 hours have passed. So distance is dependent on time. Time is not dependent upon distance at all. So what is the independent variable? We have time is the independent variable. Or we could say x is the dependent variable. Independent variable. And what's the dependent variable? We see here, distance depends upon the time. Let's write this out. Distance, and we see that's represented with the variable y. So how far does the train travel each hour? We can easily see that after 1 hour it's 50 miles, 2 hours 100, 3 hours 150. So you can see increments of 50 miles per hour. So how far does the train travel each hour? We can write in 50 miles. So then jumping down after B, it says the relationship between the distance traveled by the train and the time in hours can be represented by an equation in two variables. So we can see y, distance traveled, equals distance traveled per hour times the amount of hours. Okay, so y equals 50 times x, or you can even have 50 times x equals y. You can switch those around as well. So let's continue to take a look at this problem on page 338. It says describe how the value of the independent variable is related to the value of the dependent variable. Is the relationship additive or multiplicative. In other words, are we dealing with addition or multiplication? So we can see the answer. It says the value of y is always 50 times the value of x. Okay, so we can jump back on page 337. Value of y is 1. Value of y is 50 times 1. 100. 2 times 50 is 100. 3 times 50 is 150. So we can see that the value of y is always 50 times the value of x. So we can see it's multiplicative. And then take a look at number 2. What are the units of the independent variable and of the dependent variable? So we can see independent variable, we're looking at hours. Remember, that was time. Dependent variable, the units we're dealing with miles. Remember, we know it's the independent variable because the number of hours were not dependent on how far or how many miles the train traveled, but the miles were dependent upon how many hours have passed. Okay, so now we can see that a rate is used in this equation. What is the rate? And we know that it is 50 miles per hour. And let's write this in together. So 50 mph, miles per hour. So now we've looked at identifying independent and dependent quantities from a table. Now we're going to take a look at identifying independent and dependent variables from a graph. So we can see on page 338, it says in Explore Activity 1, you use a table to represent a relationship between an independent variable, which was time, and a dependent variable, which was distance. So we can also use a graph to show this relationship. So let's take a look at page 338, the problem down below. It says an art teacher has 20 pounds of clay, but wants to buy more clay for her class. The amount of clay, which will be represented by X, purchased by the teacher, and the amount of clay Y available for the class are shown on the graph. So we can see on the graph it starts out at 0 on the x-axis, 20 on the y-axis, because it started out with 20 pounds. Then as a teacher bought 10 pounds, it was 30 pounds available for the class. As the teacher bought 20 pounds, you can see there was 40 pounds available. As the teacher bought 30 pounds, there was 50 pounds available. So we can see that it's always going to be 20 more than what the teacher bought. And why is that? Because the teacher started out with 20 pounds already. So let's take a look at letter A. It says if the teacher buys 10 more pounds of clay, how many pounds will be available for the art class? So right away, start out with 20, bought 10 more pounds of clay, you can see 30 pounds would be available. If the art class has a total of 50 pounds of clay available, how many pounds of clay did the teacher buy? And then how can you use the graph to find this information? So we know that if the art class has a total of 50 pounds, we can see within our graph, has a total of 50 pounds, how much did the art teacher buy? The art teacher bought a total of 30 pounds. Now let's take a look at the explanation. What we can see, we want to find the point on the graph with the y-coordinate of 50. So we can see on our graph, and even in your book, the y-coordinate is 50. And then we find the x-coordinate at this point, which is 30. Okay, so we can see clay bought by teacher, it's 30 pounds. Available to class is a total of 50 pounds. Why is it 20 pounds more? Because remember, the art teacher started out with 20 pounds. And we can see that in our graph because the first point on the graph had an x-axis of 0, y-axis of 20. And we can also see from the label that 20 represents the amount of clay available for the class. Now let's continue to take a look at this problem on page 339. Now it says, what are the two quantities in this situation? And now the two quantities, or the two items that we're dealing with, we know the clay bought by the teacher, so let's write this down, and also the amount of clay available to the class. So those are the two quantities that we're looking at. Clay bought by the teacher and the amount of clay available to the class. Now, let's see which of these quantities depends on the other. So the amount of clay available to the class depends on the amount of clay bought by the teacher. So we would say the amount of clay available to the class is the dependent variable, and the amount of clay bought by the teacher is the independent variable. And you can see those two questions are answered. What is the independent variable? Clay bought by the teacher. So we always knew that there was always 20 pounds of clay from the beginning. Now, what was the dependent variable? Clay available for the class. And we know that because as the clay bought by the teacher increased, the clay available for the class also increased as well. Okay, so we can see that the teacher bought 10 pounds of clay for the class, which also increased the clay available for the class. So since the clay bought by the teacher, as that increased, it made the dependent variable increase as well. So taking a look at C, it says the relationship between the amount of clay purchased by the teacher and the amount of clay to the class can be represented by an equation in two variables. So we can see the amount of clay, y, equals 20 plus x. So we can see that would be the equation with those two variables. So in other words, the amount of clay available will equal 20, why 20? Because that's how much clay they started out with, plus x. Now let's take a look at D. It says describe in words how the value of the independent variable is related to the value of the dependent variable. We've kind of talked about this already. So we can see the value of y is always 20 units greater than the value of x. So value of y, the amount of clay available, always 20 units greater. Why was that? Because the teacher started out with 20 pounds of clay at the beginning. So let's take a look at this for number 4. It says in this situation, the same units are used for the independent and dependent variables. Now, how was this different from the situation involving the train in the first Explorer activity? We were talking about the time and distance. So what we can see here, this is different, and let's write this down. The other situation involves two different units, miles and hours, and within what we're talking about now, the second problem, we're just dealing with pounds of clay because that's what's available to the class and that's what the teacher is buying. So for number 5, it says tell whether the relationship between the independent variable and the dependent variable is multiplicative or additive relationship. Now, since we're dealing with addition, we can see that that would be an additive relationship. In other words, we're not multiplying these two quantities together or anything like that like we did for the first problem. We're just adding the amount of clay available for the class as the amount of clay is purchased. So that would just be additive. Let's write that down. So for number 6, what are the units of the independent variable and what are the units of the dependent variable? So we know that, remember, the independent variable talked about clay bought by the teacher, dependent variable, clay available for the class, but the units that we're talking about would be pounds for the independent variable, clay bought by the teacher, we can see which would be x, and then the dependent variable, amount of clay available, would be pounds as well. And let's write that down together. Now we're going to move on to page 340. It says describing relationships between independent and dependent variables. And let's read through this together. It says thinking about how one quantity depends on another helps you identify which quantity is the independent variable or which quantity is the dependent variable. In a graph, the independent variable is usually shown on the horizontal axis, and also the dependent variable is on the vertical axis. So it says, example 1, it says the table shows a relationship between two variables, x and y. describe a possible situation the table could represent, describe the independent variable in the situation. So we can see the independent variable is x, dependent variable is y. So we have 0 and 10, 1 and 11, 2 and 12, 3 and 13. So you can see as we add 1 to the independent variable, the dependent variable increases by 1. As we add another 1 to x, y increases to 12. As we add one more to x, making it 3, y increases to 13. So we could say that the table could represent a lot of different things. Just as just an example, we could represent Gina's savings if she starts with $10 and adds $1 to her savings every day. So we could see the independent variable x is the number of days she has been adding money to her savings, and the dependent variable y is her savings after x days. Now, why would independent variable be x and dependent variable y? Because the independent variable, the number of days are passing. That does not matter. Okay, what matters, or that's not being changed at all, depending upon the amount of money that Gina has. However, what is changing is we know that for each day, Gina is adding $1 to her savings. So because after each day passes, $1 is being added, that changes that dependent variable every time. So 4 and then 14, 5 and then 15, and so on. So what we could see here for letter B says the graph shows a relationship between two variables. Describe a possible situation that the graph could represent. Describe the independent variables. So we can see we have the x-axis is in line with 1, y-axis is 12. Second axis, x-axis is 2, y-axis is 24. 3 and 36. So we can see, before I jump into this, that would be an additive relationship. So you can see as 1 was added to the x, 1 was added to the y, and so on. So let's jump back to letter B. We can see all these different points on the graph. And just a real world example, you could say the graph could represent the number of eggs in cartons that each hold 12 eggs. The independent variable is x, is the number of cartons. The dependent variable is y, the total number of eggs. So as x increases, y increases as well. As x goes to 1, y goes to 12. X goes to 2, y goes to 24. You can see as the x increases, the dependent variable will increase as well. So we can see what other possible situations that the table and graph and the examples could represent. We could say a lot of different scenarios. Paul has 10 DVDs and buys more. Independent variable would be number of DVDs he buys. Dependent, number he has left after he buys a certain amount of DVDs. So the graph could be 12 photos fit on each page of a yearbook. Independent variable, number of pages. Dependent variable, total number of photos on X pages. So that those two could be some examples. So let's take a look at 8 and 10 together. So once again, we have a real world value just based upon this table. You can make pretty much anything up. The thing is that you have to understand is that the X will be the independent variable, y will be the dependent variable. So you can see for letter A, I want you to read through my example, so that would give you an example of this. And then also for 10, I want you to read through that as well. We can see that we have a graph where 1 equals 3, 2 equals 6, 3 equals 9, 4 equals 12, 5 equals 15 on the graph. Okay, so you can see a real world example from those as well. It's important whenever you're creating a real world example that you understand whether it's an additive or multiplicative relationship in order to make sure that your real world example matches the data that you're looking at. Now I want you to take a look at number 1 on page 342, and I would like you to work on this independently, and you can work on this now. So we can see time is the independent variable, cost is the dependent variable, because cost depends on the number of hours rented. Now I would like you to work on number 2, fill out the chart, also complete B and C, and you can work on that now. Okay, so you can see the answers for number 2, and we are going to wrap up our video now. And it says the essential question check-in: how can you identify dependent and independent variables in a real-world situation modeled by a graph? So sample answer: the dependent variable is the quantity that depends on the other variable. Also on a graph, the independent variable is usually shown on the horizontal axis, and the dependent variable is on the vertical axis. So this concludes the video on independent and dependent variables in tables and graphs. If you have any questions about this concept, please come and see me.